Hey, good evening, everybody. We're back for a special weathercast here. We've got weather going on in Oklahoma. And I was working on the book last night and was up pretty late, and I ended up waking up about 4 or 5 this afternoon, and I noticed it was like summer, and there's like gnats in here, a couple of gnats. And then I look up at the radar, and there's storms going on in Oklahoma, so pretty crazy stuff. So I'm checking things out and trying to get my windows all situated so we can do this webcast. So let me work through that. All right, so we've got the surface analysis here. We'll take a look at the conditions. Let me bring up my preview window. Okay, so there we go. There's the weather analysis in Oklahoma at this time. So what we're seeing here, fix my monitor. Okay. Southerly flow coming up from the Gulf, and we've got some fairly moderate moisture. I don't see 70s on the map, but I do see a few upper 60s right here at Ardmore. And let's see, let's check east-west. See, this is kind of a useful presentation here because I haven't looked at anything today. So I'm kind of showing you how I go about putting the weather situation together. So there you go. I'm looking east-west through Texas to kind of look at the moisture supply. And I see lower to mid-60s here around Mineral Wells, going to Dallas-Fort Worth. Now I get into solid mid-60s, and then we pick up 66 around Sulphur Springs, Mount Vernon, and Longview. Yeah, there's a 70 right there at Longview. So this is, yeah, actually here's some 70s right there in Arkansas. Okay, see, this could be a factor later on tonight. Very moist conditions there, and backed winds, which could mean curved photographs there in eastern Oklahoma. So this is a situation that could get a little worse as the night goes on and the storms move into eastern Oklahoma. Now, we do see the cold front coming down out of Kansas. And there's the leading edge of that. And then the dry line goes from just west of San Angelo to about Sweetwater, and then intersects at a triple point just south of Vernon, Oklahoma, or Vernon, Texas. So there's the dry line. So this area right here around Vernon to around Quanah, Knox City, this is a triple point region, kind of a large subsynoptic scale area. So this is where we would expect possibly low pressure development. This is kind of a ripe area for mesolows. So this area in here, this could be an area where we see kind of like large scale backed flow. So this is kind of like where we would have to watch things from hour to hour. But we could also have smaller scale mesolows developing along the cold front. That's always a possibility. However, for the most part right now around the Lawton area, everything is responding to the strong heating and maybe some of the baroclinicity along the leading edge of the cold front right there along the Cap Rock. Let's take a look at theta E temperatures, see if I can get that to come up. Theta E kind of, it's a measure of buoyancy. So assuming the upper conditions are exactly the same across the area, theta E will tell you where the most buoyant parcels will be. So assuming that's the case, the higher theta E's are right there around the Lawton and Ardmore area. Looks like a little bit of weakness in the field in Arkansas. Actually, that's There's kind of a locally high value right there, probably due to that 73 dew point. But for the most part, yeah, the dew point field is a little bit weak there in Oklahoma. Actually, now I'm seeing that there's like two values of 70 right there. So I'm not too clear exactly how far northwest and southeast the moisture goes, but there could be at least a little pocket of moisture right there in that area. Can definitely make out the dry line. There it is, just west of Abilene near Sweetwater to probably about Vernon. I'm just kind of going over things here. So I think that's probably maybe a little more accurate there. What I'm doing is I'm kind of working up a very quick surface analysis there. So all of this air back in here, this is all the dry sector. Okay, let's take a look at the radar. We do have a tornadic storm. This is always a bad area for Oklahoma City. The May 3rd, 1999 outbreak formed in this area. Storms formed exactly right there and tracked right up I-44 towards Moore. There's also been a few other situations. I'm trying to think, maybe May 10th, 2010. Storms developed in that same area there. And this is the one cell that I'm watching right here, just west of Lawton. And I think this is an old frame. Let me bring this forward. Yeah, there we go. So we've got the storm just looks like just northwest of Cereal, Oklahoma. This is I-44 right there. And then Oklahoma City is up at the very top, up in this area right there. So, of course, this definitely bears watching. And whether this is going to stay severe depends on how back the winds are and the moisture levels up through that corridor. Let me see if I can bring that up. What we should do is go to the Oklahoma Mesonet. Let me bring that up. All right, so there's the current Oklahoma Mesonet. Yeah, it looks like our cold front is situated somewhat like that. Some very cool conditions back behind there. And I think this plot right here may be outflow. Just that's pretty close to that storm there near Lawton. So looking up the I-44 area, 66 all the way up and down. So I don't see much of a change in the environment as the storm moves to the northeast there. A lot of times in situations like this, you will have a little bit of a drop-off there in the moisture. Temperatures will be coming down to maybe 63, 62 in this area. That's especially true when you have a return flow situation and the moisture hasn't really established itself. But in this situation, it looks like we do have plenty of moisture all the way up. Let me bring up the, let's see, where we're going to get satellite data. I think I'm going to go to weather.us, and that's always a good quick source. So what we do is we go to satellite images and go to USA. They don't really make a very strong distinction between the different types of imagery, so you kind of have to use your meteorological knowledge. Day and night, that's going to always imply infrared. Day only, that tells you it's visible. So, visible imagery. Let's bring that up. Okay, so there's our storm right there in Oklahoma City area. Let me switch the type of satellite imagery. I can probably get this to look a little bit better. Oh, they got some mesoscale sectors. That's interesting. Let me check that out. Okay, it looks like those sectors are not working. I'm going to also try the color HD. Sometimes that looks a little bit better, and it appears that that frame is a little bit too dark there. Yeah, see, we're losing daylight here, so the frames are not quite as easy to see. However, what I'm looking at is this area right here. I'm getting an idea of what the inflow into those storms is looking like. And it looks rather stratified there. A lot of stratocumulus layers right here through Wichita Falls to Gainesville. I don't see a lot of like cumulus type streets feeding into those cells. And in fact, the moisture actually looks a little bit depleted right here southwest of Wichita Falls. So I think as the system moves into the deeper moisture, I mean, look how that's a pretty significant layer of moisture right there. That implies that it's rather deep through that region. So we do have the potential for this storm to keep its current intensity as it moves up I-44 there. So it does definitely bear watching here. I'm going to bring up Megitis here. I'm hoping one of these days we are able to get the next generation GOES satellite data through Megitis. That would really be nice. However, it's still very useful, which is why I'm bringing it up. Let me see what we got going on in chat. I got a few people in here. Ryan Toomeys, Thomas Copeland, C.K. Sinovitz, south of Fort Sill there, watching the weather go by. Yep, Ryan there pointing out the wild evening unfolding in western Oklahoma, softball size and a few tornadoes, watching live on the ground. Jeff Petrosky is on Periscope, according to Ryan there. Severe Studios running live. Large tornado passing Cache, Oklahoma. Okay. Yeah, so definitely a few chaser streams that you all can check out. So yeah, feel free to pull up another browser window and see if you can get some of that going there. Michael Brow here. Also, Diane Augustine in Altus. Dry there at this time. Okay, so let me get the satellite data going. So what we need to do is go to Satellite Imagery and pull up the image list. So we can only use visible imagery here for about another 20 or 30 minutes, and then we're going to have to switch over to infrared. I'm going to pull up the last 20 frames so we have some older data to look at. And let me get the sector set up here. Bring that down to Oklahoma. Okay, so let's do that. Okay, so this may affect the stream just temporarily for a couple minutes while these frames load. We've also got the level 2 data coming in, so that may have an effect there on the stream also. So we'll just do the best we can here. But there's the current imagery storm there, just north of, let's see, west of Elgin there. Southwest of Apache. And let me look at the visible, or the velocity. Okay, definitely a lot of cloud motion inside that storm there. Okay, good, our frames have come in. Okay, let me get an idea of what the velocity has looked like in the storm. We've got to keep in mind that the radar is to the southwest. This is the Frederick radar. So what we see here is outbounds right there around Cache and inbounds right there. So at this point in the radar imagery, the velocity is kind of spread out. This is around 6:03 p.m., about 45 minutes ago. And we see the velocities look kind of compact right there. And this is without storm relative velocity. I'm just kind of looking at what's going on here. Some very high velocities right there. Strong couplet. Okay, so let me go ahead and bring up the storm relative velocity. I've got an idea of the motion here, so I'm going to put that in. This is not showing the kind of velocities I would expect. I'm seeing in this red area, it looks like about 18 knots out, and then way over here about 40 in. So I may have to go up to the higher tilts here. I mean, this area here looks pretty good. Let me check that out on the reflectivity. Yeah, it looks like some sort of rotation right there. So this rotation has a diameter of about, let's see, about 2.5 miles. And we're looking at about 48 out, 37 in. That's about maybe 85 knots, around 2.5 miles wide there. I'm thinking that's probably a mesocyclone there that we're seeing. Although right in here we see some very tight gate-to-gate shear. That's about 60 knots right there. This was about 17 after. I'm still kind of putting things together here, seeing what's going on. So the very tight shear located right there in that storm. And then the velocities, the very tight shear spreads apart. Okay, so this is the current imagery at this time. This is the 0.4 tilt, and there is some very high, assuming this isn't aliased data, I think that's some very tight gate-to-gate shear there. That's about, let's see, 13 versus 37. That's about 50 knots of shear there. So yeah, that's still in that updraft area right there. This is kind of where the rain-free base is. Back in here we have the rear flank downdraft. And then on the other side, in here we've got the forward flank downdraft. Some of the largest hail that we're going to see in a storm like this is going to be in this area and possibly wrapped around a little bit into the RFD. Let's see what it's picking up for precip type. Oh, we don't have that in GR level 2. Okay. Well, never mind that. We can take a look at ZDR. Generally, the lowest ZDRs are going to be associated with large hail. It's got a much different shape than a falling pancake-shaped particle, so what we look for here are very low values, and that would be in the gray right in this area here. It's very noisy, so this could be an area of maybe a little bit of large hail falling out. I'm going to put the dot right there. So yeah, could be a few bits of large hail coming down in that rain-free base area. But I would expect some of the larger hail to be actually kind of in this area right there, especially where we have the high reflectivity. Okay, let's see here. Let me take a look at the spectrum width. The very high values there, suggesting the inflow air. So yeah, this is probably all the inflow coming into the storm. And let's see here. Let me go up to some higher tilts, see what that's showing. The rotation not looking particularly strong at this time. Up in the higher parts of the storm, up at about 8,000 feet, yeah, now we're starting to pick up the higher rotation. We see about 47 out in this area here, and then about 20 in. So that's about 70 knots of shear right there. And it's kind of a convergent rotation. And then at the higher tilts up above 8,000, still showing a convergent rotation. This is up at 18,000 feet. And then once we get into the highest parts of the storm, this is up at 38,000, the outbounds, they shift from here over to the far side of the storm, and now we're picking up the upper level divergence like that right there. So this kind of gives you an idea where the updraft is in the upper part of the storm, probably somewhere back in here. Pretty much right over the updraft area, which makes sense. So let's check out what the reflectivity looks like at this level, 38,000. And that's the top of the storm there. So maybe we're picking up a bit of the larger drops, maybe a bit of the hail up at the top of the cloud right there. And it's kind of got the look of maybe Maybe this is the very top of the updraft, and maybe this is where some of the larger hail has kind of bubbled out of the top right there. Okay, so there we go. There's our storm right there, tracking up I-44, coming up on the Chickasha area at this time. And it's starting to take on kind of a linear appearance here. Possibly an MCS coming together. On this tail end storm, it looks like we are seeing possibly the outflow boundary right there. Spectrum width, yep. That's pretty clear cut there. The higher spectrum width out ahead of it, showing the inflow air into that storm. And then up at higher tilts, let's see what that looks like. Yep, up at the higher tilts, it kind of overrides the boundary at the lowest levels. It was way out here. So it seems to be showing a little bit of the slope of that outflow. And then at the higher tilts, where the beam is so tilted, it's hard to make much sense of the data. Okay, let me take a look at the chat here real quick. Nice upper rotation. Is Norman going to be okay? There's no way to tell at this time. The cells are definitely going to be there in a couple of hours. And they are starting to look a little bit more linear, more cell competition, so that could be one thing that will help the Oklahoma City Norman area. What we had earlier, you see how the cells had a more discrete appearance. This was a little bit more worrisome earlier. One cell there, and another here. And then what we have at this time, you can see how things are just starting to form a little bit of a line there. And yeah, much earlier, this was about 6 o'clock. This is when I was starting to scramble to put the webcast together. This was definitely looking pretty bad there earlier. So we'll just take a look at this older data here. That looks like a textbook classic supercell there. You can see the hook right there. Inflow coming right into that storm there. And then the outflow from the storms kind of feeding into that area of rotation right there. So again, this was about 6:03 p.m. And let's see what the storm looked like at higher tilts. It's got a very slight LP-ish look. Okay, then earlier the velocity looked like this. This is the storm relative velocity. Yeah, that looked like some fairly close gate-to-gate shear. 12 out and 25 in. That's about 30 to 40 knots right there. And that was right in the center of that hook. Spectrum width. Showing a very interesting pattern. So you see that right there. It's kind of pretty, some of the stuff you see in the data there. So this is all the inflow air kind of feeding in and wrapping into the circulation. And then the more lower values, this is the outflow. So eventually that's going to include the circulation, and then we would see that move to the back part of the storm, and then possibly new development out in the forward flank. So let me run the spectrum width and just see what that did real quick. Yeah, that definitely does have a very steady state appearance. And then as we get further along, this moves a lot further from the radar. Let's see just how far that is. Frederick is way down here. So yeah, we're 33, 34 miles away. That's starting to get outside the range. 40 to 60, that's kind of getting into the outside of the ability to detect low-level circulations. Then outside of 60, the chances of detecting tornadic circulations are much lower. So there's the current imagery at this time. So I'm going to get a drink here and take a quick break, and a bunch of texts just came in just now. I'm going to have to take a look at that, so just give me a few minutes and I will be back. Thanks. Okay, guys, we're back again, and doesn't look like as dire of a situation as what we had an hour ago when I was scrambling to start the webcast. We've got a very... hang on a second. Got a very... starting to get kind of like an MCS appearance to this activity. Definitely further north, it looks a lot more affected by outflow. Probably a very large outpool through that area. It's a little less certain further to the south. This is the tail end storm just southwest of Lawton, so this could be an area that could always develop a little bit later. This cell here continuing to remain very dominant, even though it's embedded in that MCS. It's still showing very definite signs of rotation compared to the cells further to the south, which look to be mostly outflowish. Let me see if I can pick up the inflow into the storm. Spectrum width, that's always helpful. Yeah, it looks like that is pulling in the inflow with kind of a wave shape like that. So, yeah, this cell definitely still has potential at this time, but large outflow pool still just behind that area. Further to the south, we've got this isolated storm. Looks like it's just southeast of Vernon. Some severe weather potential in that, definitely. Then further south, a few, looks like just multi-cells all the way down to Haskell. And then this is starting to get out of the radar range. But these look like very small. So my phone keeps going off. Let me see what's going on. Hang on a second. Okay. All right, let's see what else is going on. This is probably a good opportunity to look at the SPC mesoscale analysis page. Let's see, spc.noaa.gov. If you put EXPER right after the URL, you will get into this list of graphics and mesoscale analysis graphics. This has some definite great stuff here. So we can pull up the sector for the southern plains. And this gives us an idea of the different ingredients affecting the weather in that area. So let's check out the instability. So we've got several different measures of CAPE. The simplest method is the surface-based method. This takes a parcel using the surface conditions, basically just 10 meters off the ground. It forms a parcel out of that and lifts it up into the atmosphere. So that very simple method showing a little bit weaker instability to the north, probably cooler conditions, and slightly weaker moisture up there being a factor. And then as we go southwest, we go from 1,500 to about 2,500 joules per kilogram CAPE. Anything over about 1,000 favors thunderstorms, and anything over 1,500, 2,000, that's getting into the severe range. So 2,500, yeah, definite potential there for severe weather. However, a more useful measure is by mixing the lowest 100 to 150 millibars. So that gives us mixed layer CAPE. And this is more likely what's happening. And the mixed layer CAPE shows a very similar pattern. 1,000 to 1,500, marginal severe up to the north, and then definite severe further down to the south. So the 2,000 line running about right there. elevated situations where we have like maybe a boundary to the south, maybe like say we had a warm front. That's a situation where you would use the elevated Cape plate measurements, most unstable. So this is kind of given us a similar reading here, 2000, pretty much all through this area. So yeah, Cape value is about 2,000 to 2,500 on these storms from all three measurements. I was kind of thrown off because they appear to be using different intervals for most unstable Cape. See, there's 2,000. See, what are they doing here? That looks like 500, and then it looks like they do 1,000, then 2,000, 3,000, 4,000. That's a little confusing because these other products appear to be doing it differently. This is every 500 all the way up. Mid-level lapse rates, that can be very helpful if you have kind of an ambiguous low-level moisture field. And if we want to know exactly what layers they're using, we can click on this. Hopefully they'll have the information in there. And yeah, it looks like they show us 850 to 500, and then 7 to 500. I guess we have to go down to the legend. Yeah, okay. Yeah, the legend, that's where it helps us. You can see 700 to 500. So this is about 5,000 to 10,000. This is kind of like the mid-level lapse rate. And the higher this value is, the higher the instability. So the lapse rate's definitely much higher out to the west where we've had large-scale forcing. However, they're lacking the better moisture out in that area. So highest lapse rates over western New Mexico, and let me see if I can show you what the soundings look like. I guess we might have the evening soundings. Okay, so yeah, we do have the evening sounding from Amarillo. And 700 through 500 is this layer right here. And almost dry adiabatic through that layer. But this is a good example of how we can have very steep lapse rates in the mid-levels of the atmosphere, even the surface, but very little moisture in the lower levels. We do have some elevated moisture there at Amarillo. So you see right there, I formed a parcel using conditions at 675 millibars at this layer right here. That gives me a LCL right there and a little bit of buoyancy in that layer right there. So that could give me some mid-level showers, and you can see that the algorithm they're using lifts from the surface, which is definitely not representative because there's pretty much negative buoyancy all through that layer. Pretty much all through there right there. That's all negative buoyancy. So it's actually these elevated layers which can be very much more important. Evening sounding from Norman. Let's see if that's in. Nope, not yet for Norman. We do have the evening sounding from Fort Worth, and that's showing a definite loaded gun there. We've got a dry adiabatic lapse rate from the surface all the way up to about 7,000 feet. However, the low-level moisture is a little bit on the weak side. The bottom of the dew point plot starts at about 61 Fahrenheit. And it's fairly deep, upper 50s dew points all the way up to about 7,000 feet. So if we have sufficient upper level forcing, then yeah, that could be significant. We could bring those parcels up here into this region, and this positive area would all be realized. And that's probably what's going to happen later tonight. We're going to get that forcing of that low-level moisture, and we may see moisture advection coming in during the nighttime hours as the low-level jet gets established. So we could see these values here start to come up, and then our parcel later on might look something like this right here. Actually, the environment would look something like this right there. So when we construct the lifted parcel, it would look more like this here. And there we have much more buoyancy compared to what we have now. So let me go to the high resolution rapid refresh. So right now we're constructing this with 23Z data. We don't have the 0Z data in just yet, so we don't have the full benefit of upper air observations. However, what we're looking for overnight is MCS from Oklahoma, Kansas, all the way down to the Red River. Then by midnight, situation will be looking like this. Storms moving into eastern Oklahoma and western Missouri, almost all the way to Dallas-Fort Worth. And then, wow, look at all this development way out here. That's a good indicator that we have a very potent warm sector coming together, probably very strong moisture advection combined with upper level forcing. That's what would cause that there. So depending on what the helicity is like out ahead of that, there could very well be some severe storms embedded in that. Let me see what the photographs look like at 1 in the morning in in Arkansas. I'm going to pull up Little Rock, 1 in the morning. And there's the photograph right there. Looks like a very strong speed shear up to 1 kilometer. That's a good indicator of a low-level jet there. But from 1 to 2, very little shear. The problem is there's just not much directional shear. See right here in the plots, very little directional shear all the way up to about 10,000 feet, and then only above 10,000 do we get the directional shear kicking in. So not much large photographed curvature with a big hook. There's probably just enough helicity in here to get a few severe cells going, however. But I think any severe weather would be a little bit isolated tonight because of this. And let me check a few other places. Let me try Shreveport. Yeah, a little bit more directional shear here. So we do get a little bit more of a curved photograph there. Depending on storm motion, that could favor a few severe cells. Let me try the Tyler area around Texas. Not much directional shear. However, what I do notice is that aloft, in the mid and upper levels, there's a lot less bulk shear. See how weak the bulk shear is from 0 to 6 kilometers? See, there's the plot for 6 kilometers. See that 6 right there? And then 0 right here. The distance between those two points are only about 20 knots right there. 20 knots of bulk shear, that's not going to give you very much severe weather, because that's kind of a measure of storm organization. If we go up to the north, further north, up to maybe northern Arkansas, let's look at the bulk shear there. A little bit longer. So there's actually a contribution there from the slightly backed southeast winds at the surface that you see right here, and the stronger winds up at about 15 to 20,000 feet. Out of the southwest at about 35 there. And then you go further aloft and the wind speeds are a lot higher up in those levels. See, they're getting almost 100 knots there, up at about 30 to 40,000 feet. Okay, I need to grab another drink here. So we'll be back in just a second, and we can continue with a little bit of the severe weather coverage. I'm not going to go too much longer because I've got the book project that I'm still working on. But I'll be back in just a second here. Okay, we're back again for severe weather coverage, and we can see quite a change here just over the past 30 minutes on this MCS here in western central Oklahoma, coming up on I-44 there. And what we're seeing is the outflow is starting to appear, and the storms are starting to look a little bit outflow dominant here. You can see these tail end storms are very well separated from the outflow boundary right there. So it looks like the possibility of severe weather, aside from maybe some hail and a bit of wind, is going to be a little bit weaker. I don't see much tornado risk further down the line towards Lawton. Even with a cell up around the Chickasha area down to Cement and Surreal, looks a little bit outflow dominant there. We're not picking up the outflow boundary further north up the line because of the distance from the radar. Spectrum width showing a little bit of that right there. But it appears that this is probably, this outflow pool may be undercutting the storm here to a certain extent. But still, quite a bit of rotation in this storm. And let's see how much rotation. The diameter on that rotation is about, let's see, about 2.5 miles. Looks like a pretty strong meso. And seeing about 70 to 80 knots of shear across that distance there. You can see it's still a very broad rotation there. Now this gate here, that could be a little bit stronger. Let's see, we got 40 out, 16 in. This is probably getting into the range of tornadic right there. So what you're seeing here is the large-scale meso, and then embedded in that is a smaller scale circulation, possibly a rotating wall cloud or a tornado, one of the two. But we can't tell one or the other just based off radar. This is a good example of why we need spotters. Spectrum width is showing a little bit of activity right around there, but not like a definite point like we would see with a debris cloud. So from this I can't tell conclusively what's going on in there, but it's definitely rain-wrapped. So it's going to be very difficult to see unless there's a spotter like right in that area. So yeah, that is heading towards the Chickasha area. So based on this, I would at least, take the usual tornado precautions. But the storm is looking a little bit HP-ish at this point. You can see the kidney bean shape on that right there. And then the main rotation right in the area there. Okay, so we're seeing about 40 versus 16. That's about 55. I may have to fine-tune the motion vector. Let me do that real quick. (26 versus 26). Yeah, that's good. 24 versus 22. Yeah, I'm trying to use 220 at 27 for a motion vector. Okay, so that's about 34 versus, yeah, I'm having to put in about 30 knots here for a storm motion vector, 240 at 30. So about 50 knots of very close shear across maybe 2 gates located right there. So whatever that is, it's certainly very embedded in that RFD, or in that south part of the storm right there. And looks like that area of rotation heading towards Chickasha. I don't see anything that looks like a large tornado or anything like that at this time. And then here's the large-scale meso in that storm. It's impossible to know what it's going to look like when it gets to Norman or Oklahoma City. It's still about 30 or 40 miles. But there is the possibility that could continue to hold together as it moves towards Moore or Norman. It's definitely heading towards that area right there. The cells further south, those definitely look outflow dominant at this time. Let me see if I can do some cross sections here. I'm going to do a cross section across the line right there. And yeah, you can see there's that outflow boundary right there. And there's the main storms. And I don't see too much overhang. See the main core aloft, pretty much right over the precip area. So this has kind of a non-severe appearance. Let me try going further up the line. Yeah, likewise, outflow boundary right there. The core aloft in this area here, pretty much right over the precip area. And then further up the line, I'm going to try doing a cross-section through the updraft area from about Anadarko to just south of Chickasha. And there we do see some updraft with this storm. See, there's the inflow area. That's kind of where the rain-free base is. And then up above that, considerable overhang directly above that area there. And it looks like the inflow, or the outflow boundary, kind of curves into that notch region right there. I'm going to take a look at the upper level reflectivity. So you see right here over Chickasha, I'm going to put a dot right in the center of that region. So there's that dot right there. That's the overhang up at about 32,000 feet. And then we compare that with the low-level reflectivity. And it appears it's over the southern part of that RFD kidney bean shape, almost over the updraft. In fact, yeah, some of it is directly over the updraft right here. Yeah, there's a good example of the overhang right there. So this is the RFD area, and what we would expect to see in this area, probably a little bit of rain coming down, and very likely lots of lightning coming out of there because of that very strong charge separation between the bottom part of that overhang and the ground here. So this is probably a very good region for a few clouded ground strikes and a lot of negative strikes also. All right, so let's take that out, and looks like we got the storm coming up on Chickasha right now. Let me go through the past couple frames and kind of look at the trend. Yeah, we're getting radar data here about every 1 to 2 minutes, which is good. Very good temporal density of the radar. And what we see here, just kind of a HP supercell heading towards the Chickasha area. And at this time, reflectivity is looking a little bit weak, which is good. That's good for Chickasha. Gate-to-gate shear is on the order of only about 20 knots, so I don't see much of a severe weather threat at this time. The area further out here, though, that has to be definitely watched for development. And then going further down the line, still outflow dominant. Even this cell here, this looks outflow dominant also. There's the outflow on that storm. And the reason for all this outflow dominance is due to mid-level, dry mid-level air. Let me see if I can show that to you. Let me take it all the way back to the current time. We're looking at the high-resolution rapid refresh soundings. And I pulled up a sounding here. Let's see, I'll do a sounding for Wichita Falls. So let's see. Yeah, a little bit of dry air, not a whole lot. Very steep lapse rates. Not as much dry air as I would imagine. Let me compare that with the soundings. Let's see if Norman has come in. Okay, there's our Norman sounding. And we can see the cap right there. Looks a little bit on the weak side. That's certainly easy to overcome. So plenty of positive area, and only a little very small area of negative energy from about 9 to 10,000 feet right there. But yeah, I guess there is some of that dry air, probably from the mid-levels. This region right here, about 20 to 25,000. I guess some of that has made it all the way down to the surface, and that's probably what's reinforcing a lot of this outflow that we see on the radar. So as long as we continue seeing this, the likelihood of severe weather is going to be a little bit diminished here. Some of the precip starting to move in Oklahoma City. So this is all going to be elevated here. And that's going to be good. That'll help lay down a little bit of a cold pool. That'll kind of help the activity propagate and develop a little bit further to the south. So I don't see any big problems for Oklahoma City at this time. Let me check out the current radar there at the Chickasha area. Just got a new frame. I think there's been a little bit of intensification there of the meso, but very little small-scale rotation. Yeah, it's intensified just a little bit. But it's probably just right back to where it was maybe about 20 or 30 minutes ago, 20 to 25 minutes ago, actually. A little bit of stronger shear coming together right there. Looks to be about 50 knots of gate-to-gate shear right there. Let me check for vertical consistency, going up to about 7,000 feet and not showing very much right there. Actually, the latest frame came in and it looks much different there. Yeah, compared to the last frame right here, looks like we're seeing suddenly a lot stronger outbound and a little bit higher gate share in this area here. So yeah, there is definitely vertical consistency in that circulation there. I'm not seeing a very strong inbound, however. So I'm not too sure exactly what we're seeing at the ground. It could just be maybe a little bit of rotation there in the storm, but that's going to be probably in this area right here. And definitely embedded. A lot of precip back in that region there. Looks like the rain-free base, whatever is left, is heading over the Chickasha area at this time. Okay, let me check my text here real quick. Just a few texts about our trash service. Okay, we're just waiting on the current data to come in here. Just kind of monitoring the storms as they get a little bit closer there to Oklahoma City. Looks like that circulation has kind of dissipated a little bit, heading towards Chickasha. A little bit of intensification there earlier that we saw in the bottom part of the mid-levels, 7,000–8,000 feet, but in the lower levels, not very strong at all there at this time. And then just checking down the line, these storms here not doing very much. And you have some very potent outbounds. Let me set that so it's ground relative there. Yeah, this whole area here, 67 knots outbound from Frederick. So a very strong northwesterly flow just off the surface. So it's probably a combination there of the front. I'm going to try doing a cross-section of velocity. Yeah, that's kind of hard to see there, but this is showing a little bit of the stronger outbounds. This is probably... Yeah, that's probably a post-frontal air there, and then above that, I guess there's some of the warm air riding over the top, and I think that's probably the frontal surface right there at about 6,000 to 7,000 feet above the radar site. Okay, very fast-changing situation. It seemed like just earlier we had the supercells right in that area, and they've pretty much blasted northeastward, laid down this outflow boundary that's already come through Lawton. Looks like the severe weather risk to Lawton is a lot lower than what we had earlier. And the storm around Wichita Falls, that's also looking pretty good at this time. And then further down the line, a few isolated small cells all the way down through Throckmorton down to Abilene. And this is probably about the time where we start need to change over. I'm going to change over to the Oklahoma City radar. Okay, let me take a quick look at the chat here. A lot of chat activity, so I'm not going to be able to read quite all of this. See, we got Electric Dog here and Ibrahim Zakmut, IR Master, the original. Got Tree Nelson and Ryan Toomies and Sue. Why are storms concentrated in the eastern U.S.? It's because of the very warm sea just to the south, the Gulf of Mexico. So all we need is a southerly flow coming up off the Gulf of Mexico, and I think without that, we would see a lot less severe weather. And severe weather being a lot more like what you have in China, which is where it's a little bit more isolated. Gulf of Mexico, very important. And also the north-south mountain range that helps to kind of focus the north-south movement of air masses. That's pretty big. Ryan mentioning power flashes reported on the ground. I think a lot of that's probably going to be due to wind damage. Okay, so our data has come in. There's the Oklahoma City radar. This is located just north of Lake Thunderbird. I don't know if anybody's actually gone out to this site, but that's located just northwest of, or northeast of Norman there. Just southeast of Tinker. And we're seeing the storm start to come through the Oklahoma City area, through Yukon and El Reno. So things looking good for western Oklahoma City at this point. And all we're doing is we're just kind of waiting on this cell here. And I think without this one cell being dominant, we would have a lot less of a severe weather risk with all this considerable cell competition all the way down the line. Okay, let me do a cross-section through this updraft area. You can see this is the updraft area right there. The RFD area coming through Chickasha right at this moment. And yeah, we're still seeing some overhang. But the heavier reflectivities are well to the northwest. Let me get rid of some of that, some of those roads there. There we go. So there's the Chickasha storm there. Some pretty strong motion at this time, but it's very spread out. We've got about, let's see, outbound velocities of about 62. This is the forward flank area of the storm, and then the rear flank downdraft area located right there. And that's given us some inbounds of about 20 to 25 through that area. So just kind of a large scale mesocyclone there. And let's see, do we see the outflow boundary? That's the other question. I don't see it on the reflectivity like I was able to with the Frederick radar. So we'll check out the spectrum width. And yeah, that definitely shows it. Looks like it kind of feeds there into the Chickasha storm and then maybe comes out from the storm kind of like that right there. So it looks like the cell is just kind of like working up the boundary, kind of like a little wave there. So up in the Oklahoma City area here, I put a dot. And let me try to reconcile that with the spectrum width data. Yeah, so the outflow boundary is kind of underneath a lot of this anvil level precip coming out of the anvil there. And I think the outflow boundaries are kind of situated like that at this time. Yeah, and that's kind of significant because you want to be west of these boundaries to escape much of the severe weather risk. Most of these areas around El Reno and Yukon are looking good at this time, all the way down to Binger and just north of Chickasha there. Those areas at this time looking pretty good right now. There's our dominant storm there near Chickasha coming through the town and starting up that final push-up I-44 there. This is I-44. And then I-35 further off to the east there, and there's Norman. Still seeing a pretty good notch on that storm there over the I-44 area. Probably a few chasers there trying to stick with that notch, although it's starting to get dark right now. I'm going to put a dot right there in that notch. Okay, so we've got a pretty good purple area right here. This is indicative of inflow coming into the storm. See, this is about 47 out from the radar, so probably what we have is some very strong... I think we have some very strong inflow, maybe doing something like this, just north of that dot. So I think we're kind of feeding it kind of like this right here. And then that's rising up right through that area right there. So let's check out the upper level reflectivity, go up to the top parts of the storm. And this could give you a good idea where the updraft is, because you don't just get higher reflectivities for no reason like that up in this area here. This is probably being supported underneath a very strong updraft. Let me see if I can show you an example. This is an old conceptual model from Doswell and Lemon. I'm trying to find, I know it's on the internet somewhere. Let me just look here real quick. Yeah, this is a example off the internet showing a weak echo region This is looking northwest to southeast here. So it's a little bit backwards from the cross sections we've been doing. But what we have here is the inflow coming into the storm and then rising. So what we have here is the notch, and then the bounded weak echo region up through there. And you can see that in the upper levels, the highest reflectivity is kind of over the top of that updraft. So the higher reflectivities are being kind of delayed until they reach the upper parts of the storm. They tend to fall out. Weaker updrafts around the periphery of that main updraft kind of keep those stronger particles suspended. Let me see if I can find a different cross-section. Yeah, there we go. There's a slightly better version. So that's a little bit like what we have going on right now. That's pretty much a supercell there in the Chickasha area. So the inflow is kind of coming in like that and rising up into the storm, and the updraft kind of the hail, large water droplets, they tend to form up here at about 30 to 35,000 feet, and then they fall out and get entrained into the mesocyclone. So they're coming toward you, like out of the page, and then they wrap around the mesocyclone left to right, and then they go into the page kind of like that as the hook echo. So that's kind of the way that's happening there. Let me see if there's some other examples in here. Yeah, they've got a pretty good diagram here. That's pretty cool. So there you go. There's the inflow. So higher reflectivity is right there. And it looks like this is either a storm in Australia or this is a left mover. There's another example of a bounded weak echo region. So that right there, that's the bounded weak echo region itself, and then this is the rain-free base and the notch and the inflow area. And that's pretty cool. That's a high resolution, probably a field radar. Oh, that's a time series radar. I guess they had a vertical radar pointing up and must have happened to catch it. So yeah, it's very spectacular. Some pretty neat graphics on that area. And this region right here, this is a very prominent location for, as I've mentioned, lightning, because you have a lot of ice crystals and other droplets just off the ground. And so you tend to get some good charge separation between that and the ground. So anyway, yeah, now you can put it together. There's the updraft right there over, let me put a dot. This is up at about 27,000 feet. And then we take that down to the lower levels. And then this is a little bit of the bounded weak echo region, maybe just kind of a regular weak echo region right there. And there's a little bit of a difference there because I think we're looking at different time, different volumes. So that's the notch right there, the updraft, and then above that, the higher reflectivities. So at this time, it's looking a little bit disorganized, and let me check out the storm relative velocity. Yeah, it's showing a lot of... yeah, this is kind of interesting. It's trying to figure out what's going on here. Looks like a very strong area of inflow. See that right there? It's kind of like a corridor of very strong winds coming into the area. This is ground relative velocity. If I do storm relative, I get this, and it's even a little bit stronger because the storms are moving to the northeast, and that inflow is going to look much more east to west than it would if we were looking at it from the ground like that. So whatever that is, that's a little bit significant there. I'm going to put a dot right there in the center of that. That's 56 after. That's probably the last frame. And there's the inflow into the storm. There's the outflow boundary. And outflow boundary, probably something like that there. So looks like we're still getting a lot of inflow into that storm at this time. So that would be something I would be kind of concerned about there. Probably still some severe weather potential on that for the time being. But further to the south, it looks like there is a pretty substantial cold pool south of Chickasha. Okay, let's see here. Hang on a second, I've got somebody at the store. I'm trying to see if I need anything. Okay, we had a storm out there earlier today, or when we started the webcast about an hour and a half ago. Yeah, it looks like it's dark out there. Yeah, we're losing daylight here pretty quickly. It's dark at 8 o'clock, and we're going to go to daylight savings here in a couple weeks. Right now I'm just animating the storm relative velocity, looking at that little corridor of strong inflow. Looks like it's died off a little bit. Yeah, there's the last frame. Looks a little bit weaker in here now. And the ground relative velocity has pretty much died that off. A little bit of inflow right there. So that's just west of Middleburg. And that pretty well corresponds to the updraft area right there. That's the rain-free base area, so this is where you would want spotters on the ground around Blanchard, maybe up I-44, kind of checking this out and seeing what they're able to detect as far as trends. But that outflow boundary, very prominent. There it is right there. And it's a little less harder to discern further north, but again, spectrum width, very underutilized. And I still don't know why this is not in a lot of online products, but there it is. So this is kind of a wave just kind of working up the boundary. And as the upper part of the boundary continues moving east, I guess that's going to bring it towards, the storm is going to move towards Moore or Norman here in about the next 20 to 30 minutes. So at this time, there's still potential there for severe weather. Let's take a look at what's going on aloft. It does have kind of a curved shape here. So it looks like the circulations aloft are pretty strong at this time. And there's the upper part of the cloud. Getting one little echo here at about 41,000. And then this area of higher reflectivity right there, this is up at about 28,000. That's going to overlie the updraft area right over the notch. And it looks to me like that is going to track pretty much just up into the northwest parts of Norman, I think. Maybe southern more. Somewhere up there by the airport, by probably around Robinson up to Indian Hills, maybe somewhere in that area. But that's still kind of a ways off at this time. However, anyway, it is still getting some very good inflow. All right, let me take a look at the chat. Wow, we spiked up to 25 viewers watching the storms as they head towards Oklahoma City. Let me edit the video description here. Okay. All right, just a quick look at the chat. Okay, let's see here. I'm kind of just reading through the chat messages. Yeah, new tornado warning came out at 7 from Funwood Tech there at 7:58. Ryan said the radar signature returns of the inflow boundary appear continuous. I-44, I-35 expected to be hit by 11. It's already heading into the I-44, I-35 area. It's going to be there just in the next 20 minutes. Mike says, can I explain why future development likes cold pools? Well, basically that just kind of boils down to the higher lapse rates. better instability where you have cold pools, a lot more difference between the temperatures at the ground and aloft. Hang on a second. Okay, there's our newest frame right there. Still a pretty well-developed inflow area as the storms continue to move towards the norm in more area. So we've got kind of an embedded supercell there. Looks like kind of a classic, maybe slightly HP-ish structure. And the rest of the area of storms looks like a MCS all the way from Kansas all the way down to the Red River of Texas. Tail end of the storms moving through Lawton around I-44 all the way down towards Burke-Burnett and Wichita Falls. And the tail end storms right around the Iowa City and Electra area along 287. And then we have some multi-cells further south around the Seymour area down to Throckmorton. Looks like the tail end storms just out of range there around Abilene. And let me take a look and see if we have the latest high-resolution rapid refresh imagery. This will give us an idea of what we can expect overnight. So there we go. We've got the latest mesoscale model data. So we're going to expect to see the MCS just continuing to push into western Missouri, into the Kansas City area around Chanute, all the way down to Tulsa, Oklahoma City. And let me take a look and see what we're looking at as far as helicity in western Arkansas tonight. I'm going to see if there's any change in the profiles. And it looks like, yeah, there is a little bit more curvature maybe. This is western Arkansas, showing very good curvature of the hodograph. Yeah, a little bit more directional curvature. So maybe the severe weather possibility increasing a little bit for Arkansas tonight. Yeah, more directional curvature. That's, let me bring this down into the I-30 area of northeast Texas. Less bulk shear, a little bit of, yeah, helicity. And let me see what it looks like for the Tyler area tonight. Kaufman and Canton. Yep, some directional shear and a little bit of, or some speed shear and a little bit of directional shear there, but bulk shear still on the weak side. And really it's about 20 to 25 knots, maybe 30 knots of bulk shear. Above that, that's usually where you see severe weather, and this is very marginal. At least it looks like that to me. The algorithm here going for tornadic storms around the Tyler area, at least the soundings support that. And we can look down at the bottom of this. I'm going to go over this sometime, over all of these details, and we can look down here and kind of see what the factors are. This is based on the very low LCL. You can see just how moist the profile is here. 72-degree dew points with lots of moisture just off the surface. That's going to give you very high relative humidity. Very high CAPE. Yeah, lifted parcels, lots of buoyancy there. And it's looking at helicity being a little bit less of a factor in that area. And helicities appear, again, we're looking around the Tyler, Canton, Kaufman area. Helicity about 100 to 200, so that's probably in the marginal range there. Probably in the marginal to good range. Okay, back to the radar. Let's see what's going on here. Hang on. Okay, still looking at a inflow dominant storm there around, this is coming up towards Bridge Creek. Is this in the Bridge Creek area? Yeah, it is. Starting to approach, the Blanchard area. And we're starting to get some more mirror advection activity developing around Norman. And this is definitely pretty useful here. You notice the location of the radar. This is out in the region ahead of the line. See, there's the radar. So we're kind of sampling the environment. And what this is showing us is that the clear air returns show a very backed wind profile. See that right there? Very backed winds, more than I actually expected. So let me switch off to the College of DuPage site and get the VAD wind profile. So this is probably what's helping to support that storm there in the Chickasha area, the very backed winds. Okay, so this is the College DuPage radar site, and if we go to the product menu, we can bring up the VAD wind profile there. So this is a chart that goes from older frames around 7 p.m. to 8 p.m. here. So time is on the x-axis, and then the y-axis, that's height there. So this is 10,000 feet here, and then this is 20,000. So this is giving us data every 10,000 there. And there's the latest data right there. So this is showing at about 2,000 feet. The winds are out of maybe 150 at about 20. And I think they're even more backed right near the surface. I think we're just not getting the kind of resolution we need, because I think some of the 0 to 0.5 helicity is actually what's important. And that's in between these gates here. I think we really need more we need more resolution from the VAD data. But I can see right here the winds are almost easterly in the low levels. And then aloft, this shows a little bit better. Let's see here. What we can do is we can follow the 0 line. And this gives us a pretty good idea what the wind profiles are aloft. So if we want to go up to, say, (2,000 feet above ground level, that's going to be this point here. That's where the 0 line is. And that's perpendicular to the radar like that. So it looks like the direction is about 120. At about 40 knots there. And then that becomes more southerly as you get up to about 3,000 to 4,000 feet there. So I think actually looking at this data here in the lowest 2,000 to 1,000 feet gives you a lot of useful information to modify your photographs and soundings when you're evaluating the severe weather risk. Okay, we've got the outflow boundary. It looks like it's heading into the Oklahoma City area. I think that's probably it right there. In the latest frame, it looks like it has it all the way down to northern Moore. And near that Walmart south of the Canadian River. Hang on a second. Okay, yeah, that looks good. So I think that could be the outflow boundary right there. Maybe a little bit more outflow dominant. It's getting a little bit hard to discern there on the spectrum width. But anyway, it's right there. And let's look at the velocities. Ground relative velocity still showing that we've got a little bit of inflow north of Blanchard. And then storm relative velocity, you can really pick that out right there. Getting about 50 knots of inflow, looks like, into that storm. Okay, I'm going to take just a short break. My phone just keeps going off, one message after another. I need to see what's going on or take care of that. And be back in a few minutes. Okay, yeah, it's always good when I start with my microphone off. Let me try that again. Okay, anyway, I was looking at the data around the La Crosse area. Very long MCS due to that front just to the west, and some of these cells here, they do have like a bow echo appearance. And then going into Iowa, there's the Iowa radar, so we do have that one bow echo about 40 miles southeast of Des Moines. And then going further down the line, there's the Kansas City radar. Very, very two-dimensional look. And you can kind of see how the outflow boundary is out ahead of the line about 5 to 10 miles. So this is a very good sign of outflow dominant storms. And you can see the trailing stratiform area, lots of very wet, stormy weather trailing the main line. So further south in Kansas, the Wichita Radar looking like this. Wichita has already passed the main area of storms, and then Oklahoma City, they're getting more of the discrete cells, but it's starting to take a little bit of a two-dimensional look here. There's a few cells out ahead of the line. These always need to be watched. However, these cells do look to be kind of small and a little bit elevated. Then further down at the end of the line, the Abilene radar, showing more of a isolated cell appearance, but looks kind of disorganized. We do have one cell, looks like around the Throckmorton area right there. Probably a little bit of isolated severe weather, and then these cells have a very multicellular look. So we can see how this matches up to the high resolution rapid refresh. There's the frame valid for right now, and it does seem to be verifying pretty well. It's got a two-dimensional look to the line through Oklahoma City, and then the more clustered look around the Abilene and Seymour area. So it looks like the models are pretty well on track with these storms. So those are going to be in the Dallas area, probably about 12 to 1 in the morning, into the Fort Smith area around the same time, and through Springfield about midnight. Be back in just a second. Okay, let's see here. Continuing on through the rest of the night. Looks like the high-resolution rapid refresh going for kind of a bow echo shape on some of these storms, so there could be a little bit of wind damage in the Ozarks. Heavier cells down along I-30 around Texarkana down to Tyler. Those will be coming through the I-20 area, looks like around 4 in the morning. Tail end approaching Palestine and Corsicana. And then looks like the northern part of the line starts dissipating around morning. And that's pretty common as we get the Lullaby jet start shutting down and we lose the effects of heating So most of the heavier cells looks like they're heading into Mississippi, Louisiana, and East Texas around tomorrow morning. But the tail end, let's see where the tail end is going to be. From, looks like Abilene to about Waco. Around Temple, maybe. Yeah, there's Travis County. Looks like Austin is going to not get any of this rain. San Antonio not going to get the rain either, but Houston will be getting it. So it looks like the cutoff for these storms are right in this area, and that's due to the effects of the cap keeping things kind of shut down. And the cap this evening, there it is. So if we try to lift that with maybe 84 degrees, which is not what we're going to have overnight, you can see the amount of capping we have there. So there's just no way we're going to overcome that unless there's some very strong upper level forcing, and we just don't have that in place. So back to Oklahoma, we're probably escaping much of the severe weather risk. Looks like maybe a little bit of high wind coming into that area. But the main outflow boundary looks like that's pushed well to the south through Tinker and Moore. And then there's the other part of that outflow area right there. Looks like this one little region here getting a little bit of surface inflow, and then probably a little bit of elevated inflow coming into the storm above that boundary through the Moore area. But overall, this has a little bit of a bow echo shape to it. Storm relative velocity, let's see, showing mostly outflow dominance. Taking a quick look at the just taking a quick look at the data here. Hang on just a second. Yeah, I'm looking for circulations on this. Just one little circulation right there, crossing the Red River or the Canadian River into Moore. There it is right there. And that's only showing about, let's see, earlier. '18 versus 35, probably about 20 knots of shear there. And it looks like they just put out a tornado warning for that. And there's what it looked like earlier. So that was crossing that Walmart area there just south of the Canadian River on I-44. Or I'm sorry, hang on, that was that's around the casino, the Riverwind Casino right there. I got screwed up on my geography there. Anyway, let's see what that looked like. 40 out and about 42 in, about 80 knots of shear. This was just a few minutes ago. So yeah, a little bit of a hook there. And then it looks like when I came back from looking at those models, that's about the way it looked, like this. And now we're looking at that circulation coming over the south parts of Norman, coming over the weather center right there. And looks like whatever it is has dissipated. So I think we're escaping any risk for any widespread severe weather in the Oklahoma City area. Things looking very outflowish. So there goes that little circulation over Norman. There's what it looked like earlier there. So a little bit of a spin up there just south of Highway 9. Crossed over the Riverwind casino area and then into southwest Norman, and then they put out that watch or that warning there. So that's crossing over the OU campus at this time, and we'll be in eastern Norman in the next few minutes. And then further north, the rest of the activity looks outflowish at this time. Further south down the line, looks like a lot of outflow from these cells here. And then not much going on the tail end right there. Wow, that was a very brief spin up there. Let me see where that came from. Yeah, it looks like it came together from this little meso when it was out near Blanchard earlier. Yeah, it formed out of this stuff right here. Yeah, see, that would have been very difficult to forecast. I mean, how do you anticipate that that's going to suddenly come together like that? But nevertheless, it did, and there's where it came together, and whatever it is quickly fell apart there. So now we're left with this and hardly any outbound, or hardly any rotation on that. All right, let me check the chat here real quick. Okay, Ryan says, great radar shot capturing that spin up. SPC backyard. Yeah, up at the Weather Center, they've got a observatory on the upper floor, which is pretty cool. They've got a bunch of stools you can sit in, and I'm sure probably a few of the forecasters go up there to see what's going on. Although I think the Weather Service does have kind of a view out towards the south, if I remember correctly. So they're probably watching these roll in. So there it is, the hook going over the, looks like Lindsay Street area around Classen Avenue towards East 12th. Starting to move into the east side probably around this time. And the rest of the city getting this main part of the storm further to the west. And there's that outflow boundary right there. Storm's very outflowish at this time. So now looks like the outflow is pushed through pretty much all of the city at this point. Yeah, there's 12th Street right there, and this is East 24th, and this is getting out there, and then 36th right there. So looks like that is already pushed through most of the city, and is all the way out to 36th and 48th Street, and that's all just kind of a rural area. So everything's pretty much gone outflowish at this point, which is good. There may still be some isolated severe weather here and there tonight, but I expect for the most part this is going to form up into a large MCS and continue pushing eastward through the rest of the state. Overnight we could have some scattered severe weather here and there depending on where we have localized forcing coming together, but I think for the immediate period we're kind of out of the woods here. So anyway, we've done 2.5 hours here, and I think that's probably about it. I've got dinner waiting here, and I might come back on later if there's anything significant going on. But at this point, I think I need to focus on the next book, which is underway, and then we'll just come back tomorrow and do the webcast then. Anyway, I think that's it for me. So anyway, take care, and we will get the music going, and hopefully we'll see you all tomorrow. Thanks for watching, and have a good evening.